Intermediate Math 3. This is your answers video for the assignment 4.03, 4.04. You want to try to get this done by Monday for extra credit, and this is the latest assignment that you've been given. All right, problem number 1. We're going to go ahead and do this two ways. There's a way that they want you to do it, but I'm going to show you both ways that it can be done, and for this first problem only. So the one way this can be done is by using the inverse log principle, which says that the log of if you take a number raised to a power, so 4 to the 2x, and then you take the log of that base. So in this case it would be base 4. That's how you can use the inverse to get the x out of the exponent. So let me just go ahead and write that. If we come over here and write log, and it has to be a base 4 because this is the base of the exponent. It can't be log base 10. So log base 4 of 4 to the 2x, that's going to equal, now I can put the log base 4 in front of this as long as they do the same thing in front of the other side. Anything you do to one side, you have to do to the other. Log base 4 of 64. Okay, so that's a legal maneuver. So what does this do? The key is this. Log of base 4, and then you have a base here of 4. They inverse each other. They cancel each other out. It's just like addition and subtraction are inverses. Multiplication, division are inverses. Well, a log of a base, and then you have that base inside, is going to inverse it. So what that means is this 2x simply comes out. It's no longer an exponent, it's just 2x, like that. Okay, now for this side, we don't have anything on the calculator that will do a base 4. You have a base 10 and a base e, natural log. So we're going to use the change of base rule. So the change of base rule says that the log of any base x of this argument y is going to be the log of any base you get to pick. And in this case, we want to always pick 10. So log of base 10 of y, which is that, log of base 10 of x, which is that. So we're going to go ahead and convert this using change of base. So that's going to equal, I'll go ahead and write it here, and then we'll put the answer down here. That's going to be log base 10. You don't have to write the 10. If you just write the word log, it means base 10, but I'm going to write it anyway. 64, because I want to emphasize this is the base that we're choosing for b in that equation. Log of base 10 of 4. Okay. So now we'll get out a calculator. We'll do the log base 10 of 64, log of 64. So let me go ahead and do this with the online calculator, actually, because I'm just going to assume you don't have a calculator. So I'm going to go ahead and bring that up. Okay, so if you simply go to Google and type in online calculator, okay, it brings up, actually this is a satisfactory calculator, but I'm not sure if that's going to show up on everybody's screen. It might. So I go to where it actually says online calculator, I click in there. Now it brings up a calculator that's not sufficient for what we need. It doesn't have some of the functions we need in Integrated Math 3. So we're going to go down here to the top center where it says Scientific Calculator, and we're going to click on that. And this is a calculator we can use. And there's the log. So the way you do this on this calculator, and this log means log base 10, which is what we're interested in. So I'm going to go ahead and put in the 2 that we need. We need log of 64. So you type in 64 first, and then you press the log button. It gives you 1.8, and I'm going to round that 0 up to 1. 1.81. Then I'll clear that, and then in the denominator we have 4. So we want the log of 4, and that gives us 0.6061. 0.61. Now, I'm rounding these to 2 places after the decimal just because I decided that's enough. All right, so now we're going to go back to our page, and I went ahead and wrote those 2 numbers down, log of 64, log of 4 right there. So those two, if you divide 0.81 by 0.61, or 1.81 by 0.61, and we get 2.967. But I'm going to tell you, because of the rounding, it should have actually been 3. Now, I don't want you to just always round like that, but in this case, I know it should have been 3 if I had done all the digits this had asked for. So I'm going to put it as 3. So what that means is that 2x equals 3. Divide both sides by 2. Cancel. And you got x equals 3 halves, which equals 1.5. And that's your answer for x. Now, the way you can test that is put 1.5 in for x. And I'm going to do that. I won't show that on the screen. I'm just going to do it on my calculator. Oh, actually, I'll show it on the screen. I'm not going to go to the online calculator. It's 4 raised to the power. That's the little caret there. Okay, I'll try to make this, get the glare out of the way. So it's 4 raised to the power of, and it's 2 times 1.5. Okay, 2 times, and then you put 1.5 in for x. So that's going to be parenthesis 2 times 1.5, close the parenthesis, equals, and you get 64. So it's, in other words, it's 4 to the 3rd power. That's what 2 times 1.5 equals, and it gives you 64, and that's what it should give you. Okay, if you use this, the 2.96, it'll give you a different number, but that's because of rounding. So we rounded these, so it didn't come out to be exactly right. So that's one way to do this problem, but here's the way they want you to learn to do it. It's called a common base. And what you do is you see if these 2 numbers, these 2 bases, can have a common base. So what you're doing is you're saying, can this be expressed as some number raised to a power, and this be expressed as that same number raised to a power? So you find a number that they have in common for a base, and that number would be 4. So you can say 4 raised to the 1st power times 2x. Now that simply equals 4, and I'm just putting that 1 there to demonstrate what we're doing here. Over here you would have 4 raised to what power would give you 64. If you're not sure, just do trial and error. 4 to the 1st is 4. 4 to the 2nd, 4 squared, is 4 times 4 is 16. 4 to the 3rd is 4 times 4 times 4 is 64. So yes, 64 does have a base of 4 if you raise it to the 3rd power. So this is 64 right here. Alright, so now let's go ahead and simplify this side. And so 4 raised to the 1st raised to the 2x power. And I really didn't have to put that raised to the 1st. I could have just left it as 4 to the 2x. But I just wanted to show how you're trying to find 4 raised to some power and this 4 raised to some other power. And those will each give you these bases. Okay, so a to the x, and then y on the outside of parentheses is a to the x times y. So this is simply 4 to the 1 times 2x. Well, that's 4 to the 2x. That's why I said you didn't really have to do this, but I'm just demonstrating how this looks like this, except different exponents. Okay, and over here equals 4 to the 3rd. Okay, so if 4 raised to the 2x equals 4 raised to the 3rd, then it stands to reason that 2x and 3 have to equal each other. If these terms are going to be equal to each other, then 2x and 3 have to be equal to each other. Otherwise, 4 raised to this wouldn't equal 4 raised to the 3rd power. So that means you can get rid of the 4's, in other words. So you didn't really have to use what we did. We didn't do what we did over here, which is use logarithms to do it, okay? So it's 2x equals 3, and we divide both sides by 2, and you get x equals 1.5. You could call it 3 halves if you want, but that's your answer. But it's the same answer that we got over here. Okay, so that's called the common base. All right, I'm going to go ahead and do these with you, but try to do them on your own and see if you can get them. All right, we're going to move down to number 2. So the second is 16. So we skipped over 8. So 4 is not a base of 8, so they can't have a common base of 4. So let's find a smaller number, a number that's smaller than 4 and smaller than 8, smaller than both of them, that could be a base for both of them. And the number that jumps out at you is 2. So this can be written as 2 squared raised to this same power out here. Okay, so that equals 4, right? So this entire term here is the same as this. Now over here we're going to do 2 to the what power gives you 8. That would be 2 to the third power. So 2 to the third gives you 8, 2 squared gives you 4, and then you still have this exponent to deal with. Okay, so what we do now is on this side we say 2 to the second and then raised to the 1 minus 3x. We again use this same principle right here. A raised to the x, and then this raised to this outside the parenthesis is x times y. It's these two multiplied. So we're going to multiply 2 times 1 is 2. And 2 times negative 3x is negative 6x. I simply distributed the 2. I basically put parentheses around that and distributed 2 minus 6x. And then over here we still have 2 to the third. So if 2 to the 2 minus 6x equals 2 to the third, then 2 minus 6x must equal 3. It's like, let me just give you an example. You don't have to write this down. Is it true that if 4 to the 2 plus 2 equals 4 to the fourth? Now let's see, 2 plus 2 is 4. 4 to the fourth power is going to be 256. Okay. And here 4 to the fourth power is 256. So in other words, if this is true, then this has to be true. That you can just get rid of the 4's and say 2 plus 2 equals 4. Okay, that has to equal that. If 4 raised to that equals 4 raised to the fourth, then these two have to equal each other. Okay? So anyway, just an illustration of this principle. You can just get rid of the 2's. This has to equal this. So now we're simply going to solve for x. All right, so what I'm going to do is add 6x to both sides. And over here I have 3 plus 6x equals 2 over here. I'm going to come up here to finish this up. And so 6, yeah, there we go, you have that. So I have 2 equals 3 plus 6x. I'm going to subtract 3 from both sides. And this disappears. And this is 2 minus 3x is negative 1 equals 6x. And then divide both sides by 6. That cancels. And that divide that side by 6 too. So x equals negative 1/6. And that is your final answer for that. Okay? So this one was a little trickier than the one above. 4 is not a base of 8, so you can't use 4 as the common base. So you have to find a number that they both have as a common base. 2 to the second is 4, 2 to the third is 8, so that's the one they could use as a common base is the number 2. Okay, notice we didn't have to use the change of base here. So this is the way they want you to solve these problems, not with the change of base, although it can be done. You can do it that way. Okay, let's move on. Okay, so let's go ahead and do this. So let's just ask a question. What is 32? What is a common base? Let's forget 1 over 32 for right now. Let's just do 32. And then we'll see how we deal with the 1 over 32. So what would be a common base of 2 and 32? And the answer is 2. So this over on the left side, I'm going to go ahead and write it over here, is 2 raised to the first power. And then outside you still have x plus 4. Okay. Now 32, is 2 a common base of 32? Yes, it is. 2 to the what? 2 to the 5th power. So 2 to the 5th power equals 32. Alright, but here's the thing. It's not 32, it's 1 over 32. So how do you get a reciprocal? How do you get the number, the 32, instead of being up on the top like this, it's down on the bottom? And that is you make the exponent negative. Where did that come from? Well, it comes from right here, what I was about to show you. A to the minus x equals 1 over a to the positive x. So if you have a negative exponent, it doesn't make the number negative. It just makes it a fraction, a reciprocal. It flips it. You take a to the positive x and you flip it over like that, okay? So, let me go ahead and do that. So if 2 to the 5th, shouldn't have written that negative sign there. If 2 to the 5th equals 32, then 1 over 32 is going to equal 2 to the negative 5th. Okay, like that. All right. So now you have a common base for 1 over 32 here, so that's going to equal 2 to the negative 5th. Alright, so let's distribute this. Well, 1 times x is x, and 1 times 4 is 4, so that didn't change anything. So it's 2 to the x plus 4. And over on the right, we can just get rid of the parentheses. Equals 2 to the negative 5th. Alright, so now if 2 raised to this power equals 2 raised to this power, then these two exponents have to equal each other. So you can just get rid of the 2's and just say x plus 4 equals negative 5. And we're going to subtract 4 from both sides. And that gives us, that goes away, and that gives us x equals negative 9. Okay, and that's your answer. Let's check it out. Let's see if it's true. Negative 9 plus 4 is negative 5. So if we plugged in negative 9 there, negative 9 plus 4 would be negative 5. It would be 2 to the negative 5th. And as we saw down here, 2 to the negative 5th does in fact equal 1 over 32. So 9 is the correct answer. Okay. All right, let's keep going. Okay, they just kind of keep adding something to each of these problems. So again, we have to find a common base. So the way we said we would do that in the last problem is let's take this fraction 1 over 125. Let's figure out what's a common base with 125. Leave it, and then we'll deal with the 1 over part of it in a second. So these three have a common base, okay? And you can kind of do this by trial and error, but if you had to guess one and you didn't know, you'd go ahead and guess 5, all right? So 5 to the first power equals 5. 5 to the second power equals 25. You can do this on a calculator if you can't do it in your head. 5 to the third power is 5 times 5 times 5 equals 125. 5 to the fourth power, 5 times 5 times 5 times 5 equals 625. Okay, there. So we have all the numbers that are in this problem. 625, 25, and 125. All right, so we're going to turn all these into common bases. So this one is 5 to the fourth, 625. So in parentheses, we're going to write 5 to the fourth. That equals 625, and then you still have this exponent out here to the negative x. Then this is a dot, it's a multiplication. So it's times 5 squared is 25. Put that in parentheses, and then outside put this exponent that was already there. Okay. And I'll put that in parentheses since it has two parts to it. And then finally, there's the 125. That's going to be, 125 is 5 to the third, but since it's 1 over 125, that's going to be 5 to the negative third. 5 to the negative third equals 1 over 125. Okay, so we have a common base for all of these. So now you can do what you did in the first three problems. You can simply simplify this first. So 5 to the 4 times negative x is going to be 5 to the negative 4x. Simply multiply these two together. Times 5 to the 2 times negative x is negative 2x. And 2 times negative 3 is negative 6. Okay, just all I did was distribute this 2, just like you've done many times before. And finally equals 5 to the negative 3. So again, as we saw above, if you have common bases for all of these, you can just get rid of the 5's and just go ahead and set all of these equal to each other. So that's going to equal to negative 4x Okay, now we have to use another principle here. What do we do with this negative 2x minus 6? Is it negative 4x times that or plus that? And so you have to come back to principle number 3, rule number 3. A to the x times a to the y equals a to the x plus y. So think of the 5 as the a. A to the x times a to the y equals a to the x plus y. So we have to add these two. So I'm going to put plus negative 2x minus 6 equals negative 3 over here. Okay, so we can rewrite this simply as negative 4x plus negative 2x minus 6. I can simply write that as minus 2x minus 6, okay? As long as that's a plus sign, you can just get rid of the parentheses. All right, and that equals negative 3. Now you combine terms here. So we have negative 4x minus 2x. So that's going to be negative. Well, let's get all the terms on the same side. So we're going to add 6 to both sides. These go away, and what you end up with down here is negative 4x minus 2x is negative 6x equals negative 3 plus 6 is 3. Okay, and I'll just come up here to finish the problem. So I have negative 6x plus 3, equals 3 rather. Divide both sides by negative 6. These cancel and you have just x by itself, positive x, equals 3 over negative 6 is negative 1/2. And that is your final answer. Okay? Okay, again, if you really want to go on with further math, be sure you understand these principles and cover this up. Get a piece of scratch paper. Just cover up this answer on a piece to see if you can do this problem on your own. And I would do it until you can do it on your own without looking at the answer. And this is just to help you if you really want to learn this subject and want to go on with math. You should do that. I had a little issue happen on the front, so I'm going to go ahead and do problem 5 here on the back. So there's problem 5 as it appears on your assignment. Okay, so we want to see if we can find a common base for these three. So the first thing you check is see if the smallest number is a common base of the other two. So 3 to the first, just make a list, equals 3. 3 squared equals 9. 3 to the third equals 27. 3 to the fourth equals 81. You can use a calculator. You don't have to do that in your head. And so yes, 3 is a base for 3, for 81, and 9. You see all those numbers over here. So we're going to go ahead and write that as 3 can equal 3 to the first. It's not really necessary to write it in parentheses like that. I'm just doing it to show how it looks, how the other two look the same. And that's times 5x times 3 to the fourth. That's what 81 is. And that's to the 1 minus x. And that equals 3 squared. That's what 9 is. Put that in parentheses. X minus 3. Okay, so everything is in a base 3. And this is the exponent. 3 to the first is 3. 3 to the fourth is 81. 3 squared is 9. Okay, so now we use the principle that says a to the x and then raised to the y outside the parentheses is you simply multiply the exponents like that. So it's 1 times 5x, so it's going to be 3 to the 5x times 4 times 1 is 4. 4 times negative x is negative 4x. Okay, and then that equals 3 to the 2 times x is 2x. And 2 times negative 3 is negative 6. So now we have everything distributed there. So again, if we have common bases, then all the exponents, we can simply set them down. So 3 to the 5x times 3 to the 4 minus 4x, what do you do with that? That is that they have a common base there, so that's the same as a to the x times a to the y equals a to the x plus y. So you're going to add those two exponents together, and you bring them out. So It's going to be 5x plus 4 minus 4x equals 2x minus 6. And these parentheses aren't necessary, so we're just going to write 5x plus 4 minus 4x equals 2x minus 6. Okay, so now we have to get all the x's on one side. Let's combine terms first. We can combine 5x minus 4x equals x. That's these two together. And then you still have the plus 4 there. So 5x minus 4x is x, and then you have plus 4 equals 2x minus 6. Okay, now we need to get the x's all over on one side. And we'd like a positive number for x. No minus sign in front of the x, so we're going to subtract the x from this side. Okay, these go away and you get 4 equals 2x minus x is x minus 6. Now you're going to add 6 to both sides. And that's going to be 10 equals, those go away, equals x. That's your answer. X equals 10. Okay? You could go plug the 10 back in for all of these, but those would be some really big numbers. And I don't even know if your calculator can handle it. But anyway, that would be the answer for that. Okay, we're ready to move down to number 6 here. Same thing, common base. So 3 to this times 3 to this, we need to get that as a base of 3. And we've already seen that that's 3 to the 4th equals 81. So we can go ahead and write this. I'll write it over here. So this side didn't change. The only thing that changes is this, 3 to the 4th. Okay, so we have base 3 for everything. So we're going to come down here. Remember, if it's base of exponent times the same base, another exponent, you add the exponents together. Okay, so it's going to be plus this equals this. Okay, 2x, 3x, you add those two. 3x minus 2x is x. Minus 3 equals 4. Okay, I combine those two. Now we're going to add 3 to both sides. This disappears. This becomes 4 plus 3 is 7. And the x is right there, so it's x equals 7. That's your final answer for this problem. Okay? Alright, let's keep going. Okay, now we're getting into a different type of problem. Use properties of logarithms to expand. That's the key word. Each logarithmic expression as much as possible, and then evaluate with a calculator if you can. So expand means, I'll just use the simplest language I can. It means more log. You want the word log to appear as many times as possible. Okay, so what we would do for this, so what this is log of base b, and it's two terms in here that are being multiplied. X is being multiplied to y to the third. So how do you deal with that? That's principle number 10. So if you have log of two things being multiplied, that's equal to log of the first one plus log of the second one. So they become an addition under their own log like that. You don't have to understand why these rules work. Just learn what they are to apply them. So what that means is this is simply going to become log of some base b of x, the first of the two terms, plus log of that same base b of the second one, y to the third. So that's what I mean by more log. You want to expand means more log. You want to go from the word log once to the word log twice. The only additional thing you can do to this is use principle number 12, that the log of a number raised to a power, you can take that exponent and bring it out in front of the word log, like this right here. You just brought it out in front. Okay, so that means this 3 can come out in front, so this would be log b of argument x plus 3 log b of y. Okay, and there it is. Alright, okay, let's go to the next one. This is log base 5 of 125 over y. So you have to use rule number 11 here. And that is if you have a log of two things being divided, or of a fraction like that, you take the log of the top one, log A, and subtract the log of the bottom one, log B. So we're going to go ahead and do that. Yeah, what I would really encourage you to do to learn this is just pause the video before I do an answer. See if you can do it on your own. And do that with each problem, not just this one, okay? So what we're going to say then is that this is equal to log base 5 of the number on top, 125, minus log base 5 of the number or term on the bottom. There it is, okay? All right, now you can simplify this to a number. There's a number that equals. And remember what this says. So let me write this out in words. What this is saying is what? So it's saying what exponent do you raise 5 to so that you get 125? So 5 raised to what power equals 125? So that would be 5 to the third power. That means this equals 3. This entire term equals 3. Okay, if that wasn't obvious to you that log base 5, 125 is going to be 3, what do you raise 5 to get 125 is 3, then you can use the change of base, and you could write it as log of base 10 of 125 over log base 10 of this number 5. And do that log, you do each of these on a calculator and divide this one divided by that one, and you'll get 3. Okay, so you could use change of base. All right, but we saw that 5 raised to the third is 125, so this equals 3. So that means we're going to make our final answer is going to be this. This is 3 minus, and then this term you can't simplify any further, so it's log 5y. That's your final answer. Okay, and that's all there is to that. Alright, so this video is around a little over 30 minutes, so I'm going to stop here. I'll put the rest of the answers on another video, and that will be up for you later. Okay, so have a good day, and we'll see you on the next video.